Hello and welcome to this video brought to you by Smart EduHub Mumbai, world's largest providers of topic-wise past papers. Today's topic is aluminium extraction. What is the ore of aluminium? Ore of aluminium is bauxite. What does bauxite contain? Well, bauxite contains 50 to 65% aluminium oxide, which is also called as alumina, and around 35 to 50% of impurities, which are largely oxides of silicon, iron, and titanium. You can use the word SIT to remember the impurities. So oxides of SIT, meaning oxides of silicon, iron, and titanium, are the impurities that are present in the bauxite ore. Can we use this ore directly? Well, we cannot use this ore directly because there are a large number of impurities. So first you need to remove the impurities. So how is the ore purified? This bauxite ore is basically crushed and then dissolved in sodium hydroxide. Now why do we do it? Well, aluminium oxide is soluble in sodium hydroxide and forms a compound called sodium aluminate. While the impurities, that is the oxides of silicon, iron, and titanium, are insoluble in sodium hydroxide and hence can be filtered off. So what you get is pure sodium aluminate. This is the chemical reaction for the formation of sodium aluminate. As you can see, there is a byproduct of water that is formed. This sodium aluminate is further processed to form pure aluminium oxide. That means we now have our electrolyte in place. What are the disadvantages of using pure aluminium oxide as the electrolyte? I just said that now we have our pure aluminium oxide. But the next question that comes up is, there are some disadvantages of using this pure aluminium oxide. So first we need to know the disadvantages. Well, the first disadvantage is that pure aluminium oxide has a very high melting point of around 2040 degrees Celsius. So that means the process is going to be quite expensive. Another demerit of using pure aluminium oxide is that it is a bad conductor of electricity. So we must do something in order to remove or reduce these disadvantages. So let's see what can be done. Cryolite, that is sodium aluminium fluoride, which is Na3AlF6. This can be added to pure aluminium oxide. As a result, the melting point seems to be reduced to 1000 degrees Celsius. Sometimes calcium fluoride is also added to further reduce the melting point to around 900 degrees Celsius. Thus, by adding cryolite or calcium fluoride, there are two things that work to our advantage. First is the electrical conductivity of aluminium oxide is improved, and since the melting point gets reduced from 2000 degrees Celsius to around 1000 degrees Celsius or around 900 degrees Celsius if calcium fluoride is also added. So this saves a lot of money as it reduces the energy cost. So overheads are reduced. You need to know all of this because there are many questions based on the reasons why cryolite is added. So you need to know these points. Now this is the basic setup of an electrolytic cell. As you can see, the cathode is the lining of the electrolytic cell, which is made up of carbon or graphite. And the dipping electrodes that you can see, which are made up of carbon or graphite, are the anodes. So you have the anode and the cathode made of the same material. The aluminium oxide that is used in this electrolysis process is basically a mixture of aluminium oxide and cryolite, and sometimes maybe even calcium fluoride, like I mentioned earlier. When electrolysis begins, aluminium oxide is broken down into aluminium ions and oxide ions, as you can see. Now, as you all are aware, anode is the positive electrode, so definitely it will attract the negative ions, that is the anions. And the cathode, which is a negative electrode, will be attracting the aluminium ions since they are the positive ions. So this is what happens exactly while the electrolysis is in progress. So now we have seen that the positive ions, that is the aluminium ions, are attracted to the cathode, that is the inner lining of the electrolytic cell, whereas the oxide ions have been attracted to the anode, which are the dipping electrodes. Reactions at the anode and the cathode. Anode reactions, O2 minus minus 2E minus gives you O. But all of us know that oxygen is a diatomic gas, and therefore the correct equation would be 2O2 minus minus 4E minus gives you O2. As you can see, electrons are lost, therefore oxidation is lost, and therefore oxygen gets reduced. Similarly, at the cathode, Al3 plus plus 3E minus gives you Al. Finally, molten aluminium metal is deposited at the base of the electrolytic cell as it has a high density. At the same time, you find that the overall reaction is supposed to be aluminium oxide breaking itself into aluminium and oxygen. So only two products should be seen. But you will soon find there's a third product also. So as you can see, oxygen gas is being formed at the anode and it is escaping. But while escaping, it reacts with the hot carbon anodes and burns them away. And another gas, which is carbon dioxide, is also released in the process. So eventually there are two gases leaving the anode. One is the oxygen gas, the next is the carbon dioxide gas. So this happens at all the anodes. Eventually the anodes become smaller, they get burnt away, and therefore we need to replace them while electrolysis is in progress. What are the uses of aluminium? Due to its low density, it is used in making aircraft bodies. As it is a good conductor, it is used in making electrical cables, and being unreactive, it is used in making aluminium foils. So that's all in this video on aluminium extraction. I hope you liked watching my video. If you liked, please do subscribe. Thank you. Please do subscribe if you like.